All right, so we're talking about section, I think it's 1.7. It is what we call the chain rule. And we're trying to find the derivative of f of x, where f of x is equal to quantity x squared plus 4x plus 1, quantity cubed. And what we observed is that if we just had f of x equals, x cubed, if we just had this, then what we would say is, what we would say is that f prime of x, all right, so you can see that a little bit better, would be equal to 3x squared. All right, I'll just make the square like that for right now. Is that fair? Yeah. Now the problem with this is in essence the that's just the power rule. All right, that's in essence the power rule. So we're going to invoke that same power rule here. And so what's going to happen is this 3 is going to come out front. And you're going to end up getting f prime of x is equal to, the 3 is going to come out front. And it's going to be whatever this is. So it's going to be all of this. Come on, you jerk. I don't understand. I try to be a good person. I swear to you I do. It's gonna be, thanks, Bracken. Yeah. All right, so it's going to be 3, all of this, right? And then this number is going to get subtracted by 1, right? So now we're over here somewhere, and we're going to put a 2. All right, so it's 3x squared plus 4x plus 1. Then we're going to do the square. But after we do that, we have to multiply by the derivative of the inside. The derivative of the inside is 2x plus 4. Okay? And so what the final answer will be is, the final answer, and I'll just write it here, will be f prime of x is equal to 6x plus 12, 3 times 2x plus 4, times x squared, sure would be nice if there's a shortcut for that, x squared plus 4x plus 1 squared. Okay? And that would be your final answer. Are we straight on that? All right. Now, we're going to try this next one, which will be f of x equals sure would be nice if we had square root. Lovely. Square root of 2x plus 3. All right. Square root of 2x plus 3. I'm going to pause this and I'll come right back. All right. So when we have the square root, the first thing you want to do is take the square root and convert it to a rational exponent. All right. That's the number one thing. And then again, from here, really important that, this is still going to come out front, right? We're still going to get this 1/2 out front. And so we're still going to get, f prime of x is going to be, the first part's going to be 1/2. All right? The first part's going to be 1/2. And then it's going to be whatever that piece is on the bottom. You know what? Let me bring up so I can show it to you a little bit easier. What we would have there is f prime of x would be equal to, you're going to have this 1/2 on the here, right? And then underneath there, you're going to have that square root of 2x plus 3. Does that make sense? But what you have to account for is the derivative of this piece. All right? We have to account for the derivative of the inside piece. And so we have to multiply this by 2. Does that make sense? We have to multiply that by 2. And then what will happen is that this 2 and this 2 will cancel. Does that make sense? Leaving me with simply 1 over the square root 2x plus 3. We get that?
Yeah, what I did was, I did the 1/2 first, right? And then I had -1/2 over here as the exponent. And then I did the chain rule, which was 2. And then I turned it into a fraction because I had a negative exponent. So I ended up with 1 over 2x plus 3 times 2 because the exponent came down, I guess.
Yeah. All right. Hold on for 1 second.
Okay.
We're going to do this next one as our next problem. We're going to work this one. All right. 1 over 3x plus 5 to the 4th. All right. I'll give you a hint. It involves taking the 4 and making it a negative exponent. All right. So we switched this to a negative exponent, right? Anytime it's on the bottom, it's just a great idea. Then, I don't have the ability to use my little arrow. The arrow is the best thing about that little program. The negative 4 will come out front. So we're going to get negative 4, 3x plus 5. Now you got to drop the negative 4 by 1, right? So this becomes negative 4 minus 1, right? And then you have to multiply by the derivative of the inside, yes? So what we get here is negative 4 times 3 is negative 12. 3x plus 5 to the negative 5. And you're done.
Okay, you don't have to change it back to a fraction.
So if you could leave it like that. If you wanted to, you could write it as negative 12 over 3x plus 5 to the fifth. And that would be an alternative form. Notice that the negative 12 stays on top because only the 3x plus 5 is being raised to the negative 5. Okay, the negative 5 is not, because if the negative 5 were raising both of these, like if the negative 12 moved down, then it would actually be negative 12 times negative 12 times negative 12. You know what I'm saying? Like that would be a huge ass number.
Yeah.
Sorry, I just said ass on YouTube. But parents, I'm a trained professional.
That's exactly the video now.
Yeah, no doubt. But that's, I mean, it would be a really, really large number, and that's, we don't want to do that. All right. Any questions on that? All right. Let's try another one. Again, I'm going to pause this for sake of dealing with it. We're going to put these two ideas together. All right. So we're going to go square root 3x plus 5 times x squared plus 1 cubed. And we'll pause it here and do this. So we're picking back up trying to solve this problem, which I know there's no delay in the video, but anyway. This is the product rule. So let me just again remind you of what the product rule is. If we have to take the derivative and we have two functions, f of x times g of x, and we got to take the derivative of this piece. Okay, the derivative of this piece, we'll call it y prime, is going to be equal to, it is the derivative of the first piece times the second plus the derivative of the second piece times the first. All right. So when you see a problem that looks like this, what you have to recognize is this is the first piece, this is the second piece. So what I'm going to do is I'm going to go ahead and color code these if I can. We're going to make this one green, and we'll make, shit, you can't even see the damn green. Sorry, that was out loud too. If you're upset, call Lakeland. We'll make this one blue, and then we'll make this one white. We'll make this one red. Okay. So as we do this, it becomes the derivative of this piece which is equal to, and again, just as a reminder, it's going to be the derivative of the inside on top over 2 times whatever this piece was. All right. It's the derivative of the inside on top, and then 2 times whatever this piece is on the bottom. That's the way all of them work. For all square roots, that's the way it works. Derivative of the inside goes on top, and then 2 square root whatever that bottom piece is. Okay, whatever that piece is. So that's the derivative of that piece. Now, the derivative of this piece becomes 3 square root x squared plus 1 plus 1. Got to drop the 3 by 1, so we get 2. Times the derivative of the inside, which is 2x. So collectively, that becomes 3 and 2x is 6x times this piece. Okay? And now we're going to apply this formula. Right? We're going to apply this formula to what we have. So the way it'll work is it's the derivative of the first piece times the second plus the derivative of the second piece times the first. Okay. Does everybody see that? It'd be a lot easier on your paper if you could just copy and paste.
Yeah.
Okay. It would be less writing. All right. Now, can we simplify that? Yeah, we could find a common denominator is 3x plus 5. There's some work we could do there, but I'm not going to worry about that. Okay. So doing the second derivative, how does that work? The 9 will come out front, and you'll get 9 8x minus 11 to the 8th. And then you got to multiply that by 8, which is the derivative of the inside. Okay? So that would be 72 8x minus 11 raised to the 8th. All right, 8x minus 11 raised to the 8th. That's the first derivative. This is asking you for the second derivative. So what does that mean? Take the derivative of this piece. All right, and how do you do that? The 8 comes out front, so it becomes 72 times 8, which is 576. 8x minus 11 to the 7th, right? Because you got to drop it by 1. But then you got to do the chain rule again, right? Which says that you got to do the derivative of the inside, which is 8. And so that would give you your final answer of whatever 576 times 8 is, which I think we said was 4. What did we say it was? 4,608. 8x minus 11 to the 7th. Okay. And with that, I'll stop the video here. This details product rule, chain rule. Didn't do the quotient rule, but that's important as well.